Welcome back to Units of Concentration. So the next most common unit of concentration is molarity, which they use a big M to show the unit of. But the real unit is moles over liters, and it's actually moles over 1 liter. So I always cross off the big M and I write moles over 1 liter. However much molarity it is, it's that many moles over 1 liter. So remember that a mole is the molar mass of whatever substance you're talking about. And you can get the moles from the periodic table, from the mass at the bottom of the symbol. So, for example, the molar mass for a common solute would be sodium plus chlorine, and there's one chlorine for every one sodium because it's +1 -1 for the charge. So the molar mass is about 58.44 grams over 1 mole. And they'll say grams per mole, but that means grams over 1 mole. So when you're making solutions, you just calculated the molar mass of sodium chloride, table salt. To determine how to make a stock solution is a really concentrated solution, and you do dilutions from this. But in order to make stock solutions, first I wanted to remind you that if you take molarity times liters, you always get moles. That's a really important thing to remember. Liters times molarity will always give you moles, but molarity times liters times molar mass will give you grams. And that makes sense, because if molarity times liters gives you moles, then moles times molar mass is going to give you grams. So how many grams of sodium chloride would you need to prepare 200 milliliters of a 5 molar solution? And that's 5 moles over 1 liter. So your grams are going to be the molarity, which is 5 molar, times the liters, which it's in 200 milliliters, but if you divided that by 1,000, it'd be 0.2 liters, times the molar mass of whatever you're making the solution of. In this case, it's sodium chloride, so it's 58.44. So 5 moles per liter times 0.2 liters, the liters cancel out, times 58.44 grams per mole, and your moles will cancel out and you're left with grams. So if you're going to make 200 milliliters of a 5 molar solution, you are going to weigh out 58.44 grams of sodium chloride, and then you are going to add deionized water up to the 200 milliliter mark. And then you'll carefully stir it, make sure it's fully dissolved, and you will have 200 milliliters of a 5 molar solution. Often, once you've made a stock solution, meaning a concentrated solution, you dilute it. So you are very careful with the stock solution so you don't contaminate it, so you don't pipette out of these solutions, you pour them into something else. And to determine how to dilute a stock solution, it's concentration 1, volume 1. Sometimes it's molarity, they'll say M1, molarity 1, volume 1, equals concentration 2, or molarity 2 equals volume 2. The reason they're saying concentration here is this works for everything. It works for more than just molarity. You can use this for diluting percent concentrations and percent volume concentrations and molarity. So here's an example. I changed it to molarity since we're doing molarity here. So M1V1 is molarity 1 initial, volume initial equals molarity 2, volume 2, final molarity, final volume. So how many milliliters of a 5 molar stock solution of sodium chloride are needed to prepare 100 milliliters of a more dilute? And it's more dilute because it's less molarity, it's 0.4. So your M1 is 5, it's 5 molar, that's your stock solution. You need to know how many milliliters you're going to take of that. So your V1 you don't know, your V1 is your X. You are going to prepare 100 milliliters of 0.4 molar solution, so you put in 0.4 for the M2, and you can leave it in milliliters because the 2 milliliters will cancel out. Just make sure that they're both in milliliters or that they're both in liters, but milliliters is fine for M1 V1 equals M2 V2. And when you solve for the V1, or if you call it X, it's 0.4 times 100, and then divide it by 5. So it becomes 40 divided by 5, and you get 8. So you find you need 8 milliliters of that 5 molar stock solution, and then you'll bring it up. You'll bring that 8 milliliters up to 100 milliliters, and that will be 0.4 molar solution. Serial dilutions are where you make a dilution, you make something less concentrated, then you dilute that, and you make it less concentrated, and you keep going down until you have a really low concentration. And so for your dilution factor for serial dilutions, you take the volume of the solution being diluted and the volume of the solvent, and you add it together, and you divide it by the total volume of the solution being diluted. And that'll tell you your dilution factor. But again, you don't have to do this. You could just keep using M1V1 equals M2V2 over and over again for every single dilution.